Let us look at the next section, students. This section contains 8 questions. Each question has 4 options, out of which one or more than one option may be correct. So let's start with the first question for this section, students. Question number 29. A solution of an optically active isomer P was taken in a container. Okay, the structure of P is mentioned. After some time, a little amount of acid or base is added to the solution containing P. Which of the given statement is or are correct? So the examiner seems to be interested in the configuration of P, and the examiner also seems to be interested in whether the substrate P undergoes tautomerism in presence of an acid, or the solution, it contains a new isomer having R configuration after the addition of acid or base. So let's start with the absolute configuration of this compound P, students. Okay, so we can just convert it into the Fisher projection. So we can stand over here and view along this line, students. So the Me will be above, the H will be below, and the CHO will appear to be on the right, and ET will appear on the left. Okay, now students, we can find out the absolute configuration of this compound by applying the CIP rules. Okay, so according to the CIP rules, we have to assign priority. So the CHO group shall be assigned the first priority because of the presence of oxygen. Now if we compare ET and Me, so the ethyl group will be having second priority and the methyl group will be having the third priority, whereas the hydrogen will be having the least priority. Okay, now if we move from 1 to 2 to 3, so it appears that we have to move in a clockwise fashion, students, and since the least prior group is already present away from us, is already going away from us, students, so the configuration of this chiral carbon has to be R. So students, the absolute configuration of P is R. So the first statement is not correct, whereas the second statement is correct. Now if we talk about the C option now, after the addition of acid, the substrate P undergoes tautomerism. Okay, so if we talk about the substrate P, students, it is an aldehyde, and we know that these aldehydes can undergo tautomerism in the presence of acid or base. So we're going to have the formation of ETCME double bond CHOH. Okay, so this is the tautomerization in the acidic medium, students. Okay, so statement C is correct. It says that after the addition of acid, the substrate P undergoes tautomerism. Okay, if you talk about statement D now, after the addition of acid or base, the solution contains a new isomer having R configuration. So this is not correct, students. The configuration of compound P present in the solution was already R. So due to this tautomerism, there will exist a new isomer which is having S configuration and not R configuration as mentioned in the option. So option D is also not correct, students. So out of these given options, we have to mark option B and option C as the correct answer to question number 29. Let us look at the next question now, students. Question number 30. Consider the given statements about allotropes of P block elements and select the correct statements. So option A, it says O2 can be converted into O3 when passed through a silent electric discharge. This is the correct statement, students. This conversion of O2 to O3 is non-spontaneous, and to make this non-spontaneous reaction spontaneous, we have to use a silent electric discharge. Okay. If we talk about the B option now, rhombic sulfur has S8 molecules, whereas monoclinic sulfur has S6 molecules. This is not correct, students. Rhombic as well as monoclinic sulfurs both contain S8 molecules only. Okay, if you talk about the C option now, at elevated temperatures close to 1000 Kelvin, S2 is the predominant form of sulfur. This is a correct statement, students. If we talk about the fourth option now, under appropriate conditions, white phosphorus can be converted into red phosphorus, which can further be converted into black phosphorus. So this is also a correct statement, students. So out of these given statements, only the second statement is not correct, and for this question we have to mark the correct answer as option A, option C and option D. Let us look at the next question now. Question number 31. The graph of probability of finding an electron versus the radial distance for an orbital X is given below. So we have a curve of PR versus R, students, and we have to comment on the correct statements out of these given options. So option A, it says the difference between the principal quantum number and the azimuthal quantum number is fixed. Okay, so if you look very carefully at the graph which is given to us, students, we can clearly see that it has one radial node only. So if the number of radial node is 1, it means that the value of n minus L minus 1 shall be equal to 1. So this means that the value of n minus L is equal to 2. So which implies that the difference between the principal quantum number and the azimuthal quantum number is a fixed number. So option A is correct, students. If we talk about option B now, if the value of psi at the nucleus is non-zero, then the principal quantum number X must be 2. So students, we have been given the graph of PR. So PR is 4 pi R square dr into psi R square. So this is the probability function, students. Okay. Now students, first let us talk about the graph. So this graph indicates that the orbital has one radial node only. So we had the value of n minus l equal to 2. So there can be different possibilities satisfying this equation. So we can have 2s, the value of n is equal to 2 and the value of l shall be equal to 0. We can have 3p, we can have 4d, we can have 5f and so on. So now the examiner seems to be interested that if the value of psi at the nucleus is non-zero, then the principal quantum number of x must be 2, students. This is a correct statement. We know that for an s orbital, the value of psi is non-zero at the nucleus. So if the value of psi is non-zero at the nucleus, it means that the orbital has to be an s orbital and correspondingly the principal quantum number will have to be equal to 2. So the second statement is correct. If we talk about the third statement now, if the value of psi at the nucleus is 0, then the principal quantum number of x must be 3. This is not correct, students. If the value of psi is equal to 0, it can be any of p, d or f orbitals, and as such the quantum number is not fixed as in the previous option. Okay, if you talk about the D option now, magnetic quantum number of x can take values from -2 to +2. So this is a correct statement, students. We can have a D orbital present. So there can be a case possible in which the orbital under consideration is D, and for this D orbital, students, the magnetic quantum number can take values from -2 to +2. Okay, so this is also a correct statement. So students, if we talk about the correct statements for this question, it has to be marked as option A, B and D. Let us look at the next question now. Question number 32. Consider the cyclic forms of the monosaccharides given below. So we have been given 4 different diagrams, students. The examiner seems to be interested in the relationship between these given compounds. That is, whether the compounds are epimers or anomers. Okay, so first if we talk about these epimers and anomers, students, we know that epimers differ at only one carbon atom. Whereas if we talk about anomers, so in the case of anomers, the difference has to be at the carbonyl carbon. Now let us look at the options which are given to us. So option A, it says 1 and 3 represent a pair of anomers. So if we look very carefully at 1 and 3, students, we can see that this compounds 1 and 3, they differ at this position. So they are different at the carbonyl carbon, students. So this is a hemiacetal, and when it is hydrolyzed, it will be converted into the carbonyl carbon. So students, they are anomers. If we talk about the second statement now, 2 and 4 represent a pair of epimers. So if we talk about 2 and 4, students, so if we look very carefully at 2 and 4, we can see that these compounds 2 and 4, they differ at the carbonyl carbon again. So they can be called as anomers. They can also be called as epimers, as all anomers are epimers. So this is also a correct statement, students. If we talk about the C option now, 3 and 4 represent a pair of epimers. If we talk about 3 and 4, students, so compounds 3 and 4, they are different at this carbon, which is not the hemiacetal carbon or the carbonyl carbon. So they have to be named as epimers. Okay, and if we talk about the last option now, 1 and 2 represent a pair of anomers. So if we talk about 1 and 2, students, these compounds 1 and 2, they are differentiated at this carbon. So this is also not the hemiacetal carbon or the carbonyl carbon. So this is not correct. So out of these given statements, students, we have to select the correct statements as option A, B and C. Let us look at the next question now, students. Consider the data given below. So we have been given 3 gases, P, Q and R, and the A and the B values have been given to us. Okay. So on the basis of this information, we have to select the correct statements out of the given 4 statements, and it is mentioned that A and B are the van der Waals coefficients. Okay. So if we talk about option A now, gas P shows the least deviation from ideality. So this is the correct statement, students. We can clearly see that out of these 3 given gases, the value of A as well as B are the least for the gas P. So this must mean that the deviation from ideality also has to be minimum or least for the gas P. If we talk about option B now, gas R has the maximum deviation from ideality. This is also a correct statement, students. The value of A and B are both the greatest for the gas R among these 3 given gases. So it has to show the maximum deviation from ideality. If we talk about option C now, gas R has the maximum critical volume. So students, the critical volume or the VC, it is represented or it is equal to 3B. So the gas which has the greatest value of B is also going to have the maximum critical volume. So we can clearly see that the value of B is maximum for this gas R. So this statement is also correct. Let us look at the fourth statement now, students. It says gas P has the least critical temperature. So if we talk about the critical temperature, students, Tc, it is equal to 8A by 27 Rb. So we can clearly see that the value of Tc is proportional to A by B. And if we talk about the gas which has the least critical temperature, it has to have the least value of this A by B. Okay, so if we talk about these three given gases, students, we can clearly see that the value of A by B has to be the least for the gas P. So the gas P has the least value of A by B, and as a result it has the least critical temperature. Okay, so the fourth statement is also correct, students. So for this question we have to mark all of these given statements as the answer. Let us look at the next question now. Question number 34. Consider the given statements and select the correct ones. So option A says in HCP the packing efficiency is approximately 74%. This is the correct statement, students. If we talk about option B now, some of the tetrahedral voids in HCP are located at vertical edges. So this is also a correct statement, students. If we talk about the C statement now, the hexagonal base can be divided into three identical rhombus. This is also a correct statement, students. If we divide the hexagonal base into three equal parts, we're going to have three identical rhombus. If we talk about option D now, there are a total of 8 octahedral voids and all lie completely inside the cell. So this is also a correct statement, students. There are a total of 6 octahedral voids and all are completely inside the unit cells. Okay, so for question number 34, we have to mark all of these answers as correct, students. Let us look at the next question now. Question number 35. Which of the given reactions involve acyl nitrene rearrangement? So if we talk about Curtius rearrangement, students, so the Curtius rearrangement is RCOCl reacting with NaN3 in presence of heat followed by hydrolysis, giving us RNH2. Okay, so this involves the acyl nitrene rearrangement, students. If we talk about option B now, we have Hofmann bromamide degradation. So this is RCONH2 reacting with Br2 in presence of KOH to give us RNH2, students. So here also there is a acyl nitrene rearrangement as there is a loss of this CO group. If you talk about the third option now, we have RCOOH reacting with N3H in presence of H2SO4 to give us RNH2 again. So this reaction also involves the acyl nitrene rearrangement, students, as we can clearly see that there is a loss of a carbonyl group. So if we talk about the last option now, pinacol-pinacalone rearrangement, so this is not a correct option for this question, students. So students, out of these given options, we have to mark the correct answer to question number 35 as option A, option B and option C. Let us look at the next question, students. Question number 36. In which of the given cases the conjugate addition, which is the 1,4 addition product, is obtained as the major product? So if we look at the options which are given to us, students, the first option contains a cinnamic system and it is allowed to react with cyanide ion, students. So this will give a 1,4 addition product. Okay, if we talk about the second option now, so MENH2, this is a soft base. It is also going to attack the soft acid center, which is the carbon atom over here. So this is also going to give us a 1,4 addition product. If we talk about the option C now, so this is also a cinnamic system. In cinnamic system, the percentage of 1,4 addition product is very high. So this is also a correct option, students. It is also going to lead to the formation of a 1,4 conjugate addition product as the major product. If we talk about the D option now, so in the D option we have an active methylene group present over here. So this is also going to generate a carbon ion in presence of base, which is diffused or resonance stabilized. So this is also going to lead to the generation of a 1,4 addition product as the major product. Okay, so all of these given reactions, they give the conjugate addition product as the major product, students, and for this question we have to mark all of these options as the correct answer.